All right. Last year, West A offered an after-school SAT prep class that students could volunteer to take. 44 students took the course and then took the SAT. The average SAT score of this group was 1220. The average SAT score for all the students who did not take the prep class was 1050. Is this situation described as an observational study or an experiment?
Observational study.
How do you know?
Because it's not necessarily comparing the two.
Okay. Other reasons it could be observational? What'd you say?
They're just like thinking about it. They're not like actually sitting down and conducting experiments.
Right. Kind of what you said. Like, they're just taking the class and taking the results, right? Nobody interfered in the process. People were volunteered for one or the other. So this is observational. Explain. No one told the students which one to take, right? It was volunteer. I'll just leave it at that. It was a volunteer thing. Nobody forced them. Nobody said you had to take this class. All right? Okay. Identify the explanatory and the response variable. Okay, this is kind of a connection back to Algebra 1. Remember in Algebra 1 you learned independent and dependent variables? X and Y, right? Explanatory and response are the statistical terms for X and Y. All right, how do you remember this? Well, guess what? Explanatory is the X and response would be the Y. So if it helps you to think about a graph, you think about which variable would you put on the x-axis and which one would you put on the y. So in this case, which one helps predict the other? Well, what are my two variables? Let's start there. Taking the class and the scores, right? So which one is the better predictor of the other? Yeah, taking the class. And the response would be SAT scores, right? So you might call the X the predictor and the Y the outcome. Maybe that helps you a little bit. That's up to you. So then can we conclude that taking the prep course will cause a student's SAT score to increase?
No.
No, why not?
Because
I agree with you.
they could be doing other things for their score to increase.
There could be other things that students are doing to increase their score, right?
And there could be things where it would be bad if they didn't study at all.
Yes. So there's extenuating circumstances, right? The class could help, it might not help. Who knows? We don't know. So no, we cannot do this. There may be other reasons, outside reasons, for SAT scores So then let's look at this. It says identify as many other possible variables that you can that may explain why SAT scores are higher than those who took the prep course than those who did not. So this is just kind of thrown out ideas. What are some other reasons they could have just done better besides the prep course?
Could it have like a private tutor or something?
Okay, maybe they had a private tutor. What else could it be?
Study for a longer period.
They studied longer. The second time they took it. What else can you think of that would affect your SAT scores? in the positive.
Study more frequently.
More frequently. I want to keep that in the studied category. What else things can you think of?
Buying one of like the prep books.
Maybe they invested in a prep book too. Yeah, maybe.
Doesn't it say that?
Okay, that's a possibility. Maybe they cheated, right? Can we measure that? No. Can we prove that? No. But could it affect the results? Absolutely. Same thing. Can we measure how much the studying helped or didn't help? Not really. You can throw out how many hours, but it's hard to connect that to how much increase there was. So these are all what we call confounding variables. Confounding variables. Variables that could affect your outcome, but are not what you're necessarily testing. Are we okay here? Okay. So an outline of the experiment is given below. This is something you will eventually be doing, is outlining the experiment. Notice it's not paragraphs of writing, it's just an outline, right? Use the outline to help write the description in words of an experiment design that would allow us to determine if the SAT prep causes an increase in the SAT scores. So here's the thing. We can't say it causes the increase unless we do a legit experiment with all the components that are necessary. You can't determine causation without an experiment to support it. Okay, just because you made an observation doesn't mean it's real, right? So let's see. What if I had to read this left to right, how would you describe this first process here?
100 juniors are randomly assigned to group 1 and group 2.
Take 100 juniors, randomly assign them to 2 groups. I'm going to call group 1 takes the SAT prep course. Group 2, no prep course. Easy enough. And then what do we do with that?
Compare your results.
Well, okay, students are going to take the SAT, right? Then results, that is a U, are compared. Okay, so in the diagram, here's your explanatory variable, and here's your response variable. When you describe an experiment, you can use the diagram method or you can use the paragraph method. It's fine. But some things you have to absolutely have. You have to have random assignment mentioned. Sometimes the question will be like, give in detail how did you randomly assign, and that's the number of the students, 1 to whatever, blah, 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 blah. Random number generated. Sometimes it doesn't ask for that. It just asks for this general description. It's just got to read and figure it out. So you've got to have an explanatory variable and a response variable. What are you comparing at the end of said experiment?
Your SAT score.
SAT scores. Not too bad, right? All right. So let's look at this page. Okay, so in the circles, you're going to put a big, oops, not that. An A, a B, and then a C. Explanatory variable. Sometimes we call that the factor. All right, the factor. Helps explain and predict the response. So that would be A. And we're trying to see if it predicts the response variable B. However, there are variables C out there that could be affecting B that we're not measuring. What do we call those? Good, confounding. So when you develop an experiment, you want to control for those as best you can. Can you do it all perfectly? No. But some things you can control for, and we will talk more about that. All right? Only when the experiment's done with appropriate measures, then we can decide if there's causation. The assumption is that there is a correlation between A and B. That's why we're doing an experiment. But we cannot conclude causation unless we've controlled in our experiment, we've randomized in our experiment, we've replicated, and I forgot the other one. We'll get there. All right, now, observational versus experiments and vocabulary. All right. If there is no treatment, like if it's just a study and there's no treatment, like nobody came in and said, you do this class, you do this class, that is just an observational study. An experiment is when treatments are imposed. The benefit is we can show causation with an experiment. There is value in observational studies, but you can't conclude this causes that based on that. Okay. What is done or not done to the experimental units, those are the treatments. All right. So when we get to experimental units, that is who or what the treatment is imposed upon, right? In this example, it was students. It could be plants. It could be plots of land or trees or whatever. Factors are your explanatory variables. A lot of times there's just one, but sometimes there's multiples. So when you have multiple factors, then you have levels. Like if it's the length of time you sleep, I could measure 5 hours, 6 hours, 7 hours, right? I may have more than one version of that variable. That's where levels comes in. And then combinations of factors and treatment. So if there's more than one factor, like it's sleep and breakfast, and there's length of sleep, then breakfast, no breakfast, then it's all the combinations therein that would be then called the treatments. All right. We'll do a lot of practice on that. So it's just the first time you've seen it. But these words kind of get twisty. All right. Now let's look at these applications. All right. You want to do these together?
Yeah.
Yes? All right. Do homes with metal roofs get worse cell service than homes with shingled roofs? Ben and Jerry are neighbors. They own an ice cream business together. Ben has a metal roof on his home. Jerry has a shingled roof. Ben and Jerry select a random sample of 50 employees. They randomly assign them to come to a party at either Ben's house or Jerry's house. When they arrive, Ben and Jerry ask them about their signal strength. Was this an observational study or an experiment, and why?
I think it's experiment because they impose, like, they randomize them and they place them into either house.
They randomized and told them which house to go to, right? So they're imposing a certain treatment. They didn't just let them choose. If they got to choose, then it would be observational. But because they randomly assign them to one of the two houses, that makes it a treatment and therefore an experiment. Okay? This would be an experiment because they were randomly assigned to either Ben or Jerry's house. All right. A study showed, still writing? I don't want to go too fast. A study showed that one factor that strongly correlates with student academic success is the number of books that the family has in their home. Researchers randomly select 100 students and measured their academic success as well as counted the number of books their family has in their home. Is this observational or an experiment? Why?
They didn't like.
They're not putting books in their home, they're just like counting the books that they have.
They're just measuring what is, right? Their academic level and how many books. They're not imposing anything. So yes, this would be observational. Families were not assigned number of books. Oops, not where. So there's no treatment imposed. Now, there's still explanatory and response variables here. Okay, what would my explanatory variable be in this case? Yeah. They're saying the number of books is a predictor of what? Yeah, academic success. However they're measuring that, we don't know. It's pretty vague. Now, explain clearly why such a study cannot establish cause and effect relationships. We'll start there. Why can I not do this study and then say, oh yeah, it is the number of books that affects academic success?
Because other things can affect academic success.
Other things can affect it, which are our confounding variables, which we're going to get to here, right? But even more generalized than that, it's observational, right? It's not an experiment. There's no randomization happening. There's no treatment being imposed, right? Therefore, you cannot conclude causation. All right, that's the first part of this. So we would say this. We would say since there is no randomization or treatments imposed, causation cannot be established. Now the second part of the question says, okay, suggest a variable that may be confounded with the number of books that the family have in their home. Let's just throw out, what's a confounding variable in this? What else could be affecting academic success besides the number of books in their home?
Classes they're taking.
Yeah, study habits. IQ, for sure, right? Can we go on for a while on that? Yeah, there's a lot of things that are confounding here that are not being controlled because this is not an experiment. Therefore, we cannot land that it's a causation thing. Are we okay? All right? Okay? All right.